So I'm now going to take you through how to install a three-phase mains single-phase solar unit. Assess the area around the switchboard for a suitable place within 2 metres of the switchboard to mount the unit. So right now I've gone on the left of the switchboard. Mark and drill mounting holes in the unit cover and drill mounting holes and 25mm holes for switchboard entry in a suitable location. Run 4 times current clamp, labelled at both ends for identification. For example, 1, 2, 3 for the mains and 4 for the solar, and a suitably sized twin and earth cable to match the rating of the circuit breaker being used to power the unit. Not smaller than 1.5mm squared cable is to be used. Also use mechanical protection where required, for example corrugated conduit. Please note the current clamps must be run with the current clamp end in the switchboard and the Molex heads in the unit. As you can see, as this is a test unit, we have some extra cables which we'll be ignoring for this section. Just noting, if it is an internal install and the weatherproof case is not necessary, you would drill and mark the mounting holes for the black unit only. Terminate the twin and earth at the unit into the main terminal provided. So I'm now going to take you through the installation process for the switchboard end of a 3-phase mains single-phase solar installation. So I'm just going to terminate the twin and earth into a suitably rated breaker. I've located a suitable lighting circuit, which is a 10 amp MCB RCD, and I'll terminate the cables into that now. Before clamping the clamps onto the mains actives, it is important to use a 3-phase rotation tester to correctly identify the phase rotation. Using a phase rotation meter, identify the phase rotation is standard or non-standard. Clamp the mains around the main actives, starting with the same phase the unit is powered from and the same phase the solar clamp is on, taking note of the current direction indicated on the current clamp. So I'm about to install current clamp number 1, which needs to be on the same phase as the single phase solar is fed into. To correctly identify which phase the solar feeds into, it is important not to manually trace the cables, but to use a phase rotation meter to discover the potential difference between each phase. Once you have identified which phase the solar feeds into, you're going to clamp current clamp 1 around the mains active of this phase. I've identified using my multimeter that the solar feeds into the white phase. I have made this phase the first current clamp to be clamped over the active, and I have also powered the unit from a similar circuit that is also fed off the white phase. Using the phase rotation previously discovered by using our phase rotation meter, we now continue to place current clamp 2 on the next phase in rotation. In this case, if it was a standard phase rotation, it would be the blue phase. We are now going to clamp the solar clamp around the solar active. It is important to take note that we have powered off the white phase and we have clamped the first mains active clamp around the white phase. Therefore, when clamping around the solar, you must clamp the single solar clamp around the white phase also. We use one solar clamp to clamp around 3-phase solar because every solar inverter has a balanced output, and we will multiply this readings later on in the commissioning process. Now you can install the last mains current clamp, number 3, on the last phase in the rotation. In this case, in the standard starting at 1, blue 2, the third will be red phase. Lastly, install the current clamp labelled 4 previously onto the solar active, taking note of the current direction. I'd like to make note that the current direction on the solar is from the inverter flowing through to the main switch. It is important that the solar phase that you've clamped onto is the same phase that the CT200 has been powered off, in this case white phase, and the same phase that the first clamp has been clamped around, also white phase. Plug the main current clamps into the current ports labelled 1, 2 and 3. It is important to note that current clamp number 1 must be clamped around the cable that the solar inverter feeds into and the same circuit that the unit has been powered from. To check that the unit has been powered from the correct circuit, it's important to use a multimeter between the active at the unit end and the active at the board end to read zero potential between the actives. If you do have 415 volts, you have powered the unit from the wrong unit and you need to change this before proceeding. Plug current clamp labelled number 2 into the port labelled phase 2. Plug the current clamp number 3 into the port labelled phase 3. Plug the current clamp labelled 4, which is the solar current clamp, into the port labelled phase 4. This solar clamp must be clamped around the same phase as has powered the unit and the same phase that current clamp 1 is clamped around. It is important that you install the current clamps in the same order as the phase rotation. If the phase rotation has been measured as standard, you need to install the current clamps in a standard 1, 2 and 3 position. If the current phase rotation is non-standard, they must be installed to suit. With the unit's main switch in the off position, turn the battery switch into the on position. The light at the side of the unit should come on. Now you can turn off the battery switch and turn on the main switch using a multimeter. Test for 240 volts across active and neutral at the main terminal. As this is a test unit and there's no power active, I cannot display the 240 volts. After you have registered 240 volts at the main terminal, you can turn back on the battery switch and leave in the on position. You are now ready to test and commission the unit. To test and commission the unit, see Testing and Commissioning section of the installer manual. Once the unit is successfully tested and commissioned, seal any holes made in the unit with silicone to maintain the IP rating of the unit, and seal any switchboard holes with fire rated sealant.